movie, we answer this old exam question and we use it as an opportunity to remind ourselves about boiling point and factors affecting boiling point. We're first asked to define what boiling point is. It's important to point out that boiling point is at temperature. It's not any old temperature. It's the temperature at which boiling occurs. Why does boiling occur at that particular temperature for a particular substance? Because at that threshold temperature, the vapor pressure of that particular substance equals atmospheric pressure. And that then allows the substance to undergo boiling. Now, if you didn't understand what I've just explained, you need to click that link there for a more detailed explanation of boiling point, because it's very difficult to memorize something you don't understand. Okay, then we're given some compounds and we're asked some questions about their boiling points. Let's start by focusing on Q, R, and S. And we can see that they are chain isomers. What does that mean? Remember that isomers are substances which have something in common and something out of common. What do they have in common? They have the same molecular formula as one another. All of these substances have the same molecular formula. What is it? C6H14. But they're not the same substance, even though they have the same molecular formula. That's because they're isomers. Isomers have something out of common too. These are chain isomers. So the thing that they have out of common with one another is the extent or even presence of branches. Chain isomers are two or more compounds which have the same molecular formula as one another, but differ in the extent or presence of branches. We can see that Q has the most branches, 2 branches, R has the medium, 1 branch, and S has no branches. Now that's very important because actually what we're doing here is we're conducting an investigation. How do we know that? Well, if it wasn't obvious already, we're asked now to explain why comparing the boiling points of Q, R, and S is a fair comparison. Whenever we ask something about a fair comparison or a fair test, we know that we're referring to an investigation and we're particularly referring to the controlled variable within, or controlled variables within that investigation. So what is being investigated here? In an investigation, we always have an independent variable and a dependent variable, and all other significant variables must be controlled or kept constant, fixed. For more about experimental investigation design, to understand these kind of variables, click there. So what do we see is controlled? What is fixed between Q, R, and S? That would be of relevance to boiling point. Now we see because they're chain isomers, they all have the same molecular formula. Why is that relevant? Because by having the same molecular formula, they also have the same molecular mass. And we know that molecular mass affects boiling point. Another thing that's relevant is that they are all alkanes. And why is that relevant? Because we know that the type of substance affects the type of intermolecular bonds between the molecules, and therefore that is also relevant to boiling point. So for controlled variables that we could mention, we could say they have the same molecular mass and they are all alkanes. Although it's not asked here, let's also quickly speak about the independent and dependent variable and what the focus question is of this investigation, because it will help us to understand everything better. We can see that the independent variable is the degree of branching, and the dependent variable is what we're going to measure as an outcome, that's boiling point. So the focus question being investigated here is how does degree of branching affect boiling point in organic compounds? And we know the answer to that question. If you don't already know it, click that link to remind you. We know that increasing the amount of branching decreases boiling point. Why is that? Because when we have a more branched substance, then that offers a smaller surface area for intermolecular forces, and therefore the intermolecular forces between adjacent molecules are weaker. Therefore, it's easier to break them apart. There's a lower boiling point. And that is relevant for answering the next question, because we're given a list of temperatures, of boiling point temperatures, and one matches each of the compounds Q, R, and S. And we have to say which one matches R. We could actually just say which one matches which. Now we know that R is the medium branched substance, and so it will correspond to the medium boiling point temperature. We're asked then to explain why. Now, that explanation of medium will probably not get you your full marks, so let's rather give a better answer. R is less branched than Q, but more branched than S. Therefore, R offers more surface area than Q, but less surface area than S. Therefore, the intermolecular forces between adjacent R molecules are stronger than for Q, but weaker than for S. Therefore, R's boiling point is higher than Q's, but lower than S's. In the next movie, which you can access at that link, we look at the next sub-question within this whole exam question. Remember, you can download this exam question and its memo from the link below. And while you're at it, don't forget to like and to subscribe and to leave me a comment.